Hey guys, in this video we will be looking at similar figures and solving proportions. So recall that when two geometric shapes are similar, their corresponding angles are equal and their corresponding side lengths are proportional. So here's a few definitions you should know for the video. A ratio is a comparison of two quantities, and a proportion is an equation that states two ratios are equal. So you're probably wondering, why does this matter? Well, in this video, we will show that we can use what we know about similar figures, ratios, and proportions to solve for missing side lengths. So let's go ahead and take a look at these two triangles here. We are told that these triangles are similar, and this means that we can use corresponding sides to set up ratios. Also, I want you to note this notation. So this squiggly line basically means the same thing as this sentence right here. So you might see this squiggly line used a few times, so just keep in mind that it means the same thing as the sentence. So let's look at the two triangles and let's set up our corresponding sides. So we can see that AB corresponds with DE, AC corresponds with DF, and BC corresponds with EF. So we will use these corresponding sides that we just found to set up our ratios, which will make proportions, and which is how we will be able to solve for missing side lengths. So let's go ahead and set up our ratios. So we have side length AB, and we will put that over our corresponding side length of the other triangle. So AB over DE. We will do the same thing for AC, put that over its corresponding side, which is DF. And same thing for BC, and we'll put that over our corresponding side length, EF. Again, we set these all equal because these ratios are equal. And to prove this, we can take our side length and plug them back in to find that they are equal. So AB is equal to 4, DE is 2, AC is 8, DF is 4, BC is 6, and EF is 3. So once you reduce these, you do see that 2 equals 2 equals 2. And since this is true, we know that we can use these ratios and set them equal to each other. So let's take a look at our first question here. We are told that our triangles are similar, and we will need to be explicitly told this each time because we can only use the ratios and proportions to solve for missing side length if we are told that the triangles are similar. So since we know this, let's go ahead and find our corresponding sides. We have AB, which corresponds to XY, and BC, which corresponds to YZ. And here, I'll go ahead and show you that we do have the corresponding side AC and XZ, but since these don't have values that are given to us, they're not going to be much use in this problem. But for the sake of setting up the ratios and proportions, we'll go ahead and include them. So we can put AB over its corresponding side length XY and set that equal to BC over its corresponding side length YZ. And then we have that AC over its corresponding side XZ. Like I said earlier, this really isn't going to be much use to us in this problem because we don't know our side lengths. But do keep in mind if we did know them, so if these had values, we could use this as a proportion instead of this, but we'll use the AB over XY equals BC over YZ because we know all the values. So let's go ahead and erase this for now. So we'll go ahead and plug in our values. So we know AB is 3, and we know XY is a question mark, so we're actually going to be solving for that. So we'll put X there, and we'll set that equal to the BC. BC is 4, and YZ is 8. So now we will cross multiply to solve for X. So 3 times 8 is equal to 4 times X. 3 times 8 is 24, equals 4X. You'll divide both sides by 4 to get X equals 6. So XY equals 6. Let's go on to the next one. So again, we are told that triangle XYZ is similar to triangle ABC. Like I said before, this squiggly line means the same thing as is similar to. And we're going to be solving for BC. So let's go ahead and Look at our corresponding sides. XY corresponds to AB, and ZY corresponds to BC. So let's set up our ratio and proportion. XY, we'll put over its corresponding side AB, is equal to ZY, put that over its corresponding side BC, and now we can plug in the values that we know. We know that XY is equal to 5, we know that AB is equal to 15, ZY is 12, and we don't know BC, so we'll put an X there so we can solve for the X, and we will cross multiply. 15 times 12 equals 5 times X. 15 times 12 is 180. We'll do 5X. You can divide both sides by 5, and X equals 30. So our side length BC is 30. So for question 3, we are told that the rectangles below are similar. So again, this is our keyword. Always look out for this. And I know in the previous problems we have used triangles, but you can apply this to rectangles too, as long as you're told that the shapes are similar, because the ratios and proportions will still apply to be able to solve for the missing side length. So let's find our corresponding sides. We have DA corresponds with GF. AB corresponds with EF. And we'll set up our ratio. So DA, we'll put over its corresponding side DF and set that equal to AB over its corresponding side EF. And now we can plug in the values that we know. So we know DA is 3. We don't know GF, so we'll put an X there to solve for that. We know that AB is 5. And we know that EF is 8. So again, let's cross multiply to get 5 times X equals 3 times 8. We have 5X equals 24. Divide both sides by 5, and we get X equals 4.8. So our side GF equals 4.8. So take a second and pause here and work through 4 and 5 on your own. Be sure to show your work so that when we go over them in the next slide, you'll know what you did wrong. So pause here and hit play when you're done. Okay, now that you're done, let's take a look at question 4. So we have that the triangles are similar, and we're finding X. So we'll see that AC corresponds with DF, and AB corresponds with DE. We'll set up our proportions, so we'll put AC over its corresponding side FD equals AB over its corresponding side DE. Once you plug in your known values and that X value you don't know, we'll cross multiply. So we'll get 4.5 times 5 equals 3X. And solving for X gets you X equals 7.5. So that is our missing side. DF is 7.5. If you didn't get that right, be sure to pause here and look over the proportion I've set up for you and make sure you have your numbers plugged in right. All right, for 5, we are given that triangle ABC is similar to triangle RST. Note that squiggly line right there. So we'll see AC corresponds with RT and BA corresponds with SR. Set up your proportion. AB over the corresponding side RS, AC over the corresponding side RT. Plug in your values and your missing value. So cross multiply to get 6 times X equals 9 times 4. You solve for X, and RT equals 6. So again, just like 4, if you didn't get this right, pause here. Make sure that you have your corresponding sides correct and your ratio, your proportion correct. And see if you can plug your numbers back in to get the right answer. So look at 6 and 7. Work on these independently to see if you can use what we learned in this video to solve these on your own.